Good morning, all of you. Good morning, all of you. Welcome to see Jayendra Bank Zone. Now we are going to discuss some important questions based on D and F block elements. This is the last session for D and F block elements. So in this session, we are going to discuss only questions, multiple choice questions from D and F block elements, especially from D and F block elements mainly. So far we have completed already D block elements as well as F block elements explanation part and some questions based on D block elements. Now we are going to end up this chapter along with summary of the chapter. So please listen carefully. All these questions are important models for all the types of entrance examinations that is JEE means, NEET as well as JEE advanced also. So please listen carefully. Let us see now example 1, question number 1. Question number 1 here. Atomic numbers of the first transition series lies from, we know transition series we have 3D series, 4D, 5D, and 6D is incomplete. So we have mainly 3 series. 6D series is incomplete, and 3D series, the atomic numbers are from 21 to 30. So answer is B. First transition series is 3D, and it lies from the atomic numbers from 21 to 30. That is scandium to zinc. Scandium atomic number is 21, and zinc atomic number is 30. This is the answer for this question. So answer is B option. Next question. The most dense metals among the following is, most dense metals means it is osmium because it can exhibit +8 oxidation state also. So most dense element among the following is not lead, mercury, platinum, and osmium is given. So answer is osmium. Osmium because it can exhibit +8 oxidation state also. So answer is a D. Next question. Which of the following is not a characteristic property of transition elements? So first option they are given, formation of colored salts, the variable oxidation states, inert pair effect, and catalytic activity. Since already we know many transition elements are used as catalysts. So option D is a characteristic property. They exhibit variable oxygen states. You can see manganese, it can exhibit from +2 to +7. So this is also correct. And formation of colored salts, as many transition elements are colored in aqueous solution because they contain unpaired electrons. So only not a characteristic property of transition elements is inert pair effect. Answer is what? Inert pair effect, because inert pair effect is exhibited by p block elements. Inert pair effect is exhibited by p block elements. It is not from d block. Inert pair effect, that is nothing but the reluctance of s electrons in bonding, is called as inert pair effect. The s electrons, the valence electrons in p block are not interested in participation of bond formation. So that's why they cause inert pair effect, and this inert pair effect property is observed only in p block elements. It is not observed in d block elements. So this is not a characteristic property of transition elements. So answer is option C. Remaining all the three are characteristic properties of transition elements. So please note down in your classwork. Next question. In the first transition series, the elements which do not exhibit variable oxidation state is R. So it can be one element or two elements or three elements. Usually we know zinc cannot exhibit more than one oxidation state. It exhibits only +2 oxidation state. And one more element is scandium. Scandium will exhibit only +3 oxidation state. +3 oxidation state. Only these are the two elements which exhibits only one oxidation state. That is zinc and scandium. Remaining all other transition metals in this group can exhibit more than one oxygen state. That's why they can form variable oxygen states. Oxidation stable, it is not stable, it is states. You can check the answer. So this is the question. So variable oxygen states is scandium and zinc only. So answer is C option. It's very, very important. Please note it down in your classwork. Zinc will exhibit only one oxygen state, that is Zn plus 2. Scandium will exhibit only one oxidation state, that is plus 3. Remaining all other elements will exhibit variable oxidation states, that is plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, maximum 2 plus 8. But plus 7 is maximum 3D series, that is manganese. Next question. Oxidation of chromium plus 3 in acidic solution forms. So chromium plus 3 oxidizes to chromate ion, that is plus 6 oxygen state. So plus 3 changes to plus 6, increase in oxidation number. Increase in oxidation number is nothing but what? Oxidation. Increase in oxidation number. In this it is plus 2, it decrease in oxidation number. In this it is plus 4 again. But here it is not forming in acidic solution, and CrO2 minus is less than plus 2. So answer is plus 6, third option. So increase in oxidation number is called what? Oxidation. Next question, question number 6. Reduction of MnO4 minus is strongly basic solution produces. So MnO4 minus, that is plus 7 state, in strongly alkaline medium it produces Mn2O7. So it is also plus 7, and this is plus 4 state. So plus 6 state changes to plus 4 plus 7 state. So answer is Mn2O7. Option is D. That's why you can say equivalent weight is equal to. So option is B, MnO4 2 minus. MnO4 2 minus, option is B, because the oxygen state of manganese is plus 7 here. Going to previous question again. So MnO4 minus changes to MnO4 2 minus, that is plus 7 changes to, reduction means plus 7, and this is plus 6. So decrease in oxidation number, and mainly in strongly basic solution, that is alkaline solution, produces MnO4 minus 2. That's why the equivalent weight of MnO4 minus in strong alkaline medium is in strong alkaline medium or basic solution alkaline medium is equal to molecular weight by 1, because from plus 7 it changes to plus 6, difference is 1. So molecular weight by 1. So answer is second option. Please note down this. Equivalent weight of manganate ion in strongly acidic medium, alkaline medium is nothing but in strongly alkaline medium is equal to molecular weight by 1, because it changes from MnO4 minus changes to MnO4 2 minus, that is plus 7 changes to plus 6 only. Next continuation. Disproportionation is shown by manganese plus 3. Will show by what is disproportionation? Simultaneous oxidation and reduction takes place for only one element in the reaction. Simultaneous oxidation as well as reduction takes place for one element only. In a chemical reaction. So usually Mn plus 3, it changes to Mn plus 7 as well as Mn plus 2, and Mn plus 7. So plus 2 it is reduction, plus 7 it is oxidation in a chemical reaction. This reaction already we have discussed. So please note down this answer. So answer is option D. Please note down this answer. Simultaneous oxidation as well as reduction takes place only for one element only in a chemical reaction. If you take manganese plus 3 state, it changes to Mn plus 2, Mn plus 7 in a chemical reaction in basic medium. So that's why the answer is Mn plus 3 only can undergo disproportionation. Remaining chromium hydroxide manganate ion, chromium hydroxide in plus 3 state will not undergo disproportionation. Next question. Question number 8. The equivalent mass of oxidizing agent KMnO4 in neutral medium is molar mass divided by how much? Very important. In a neutral medium. This should be in neutral medium. In neutral medium is molar mass, that is equivalent weight of potassium permanganate. Equivalent weight of potassium permanganate, that is KMnO4. It should be molecular weight by 3. Molecular weight divided by, answer should be 3. Second option, molecular weight divided by 3, because in neutral medium, MnO4 minus changes to, note down this also for explanation. In neutral medium, MnO4 minus changes to MnO2, that is plus 7 state, changes to plus 4. Since it is changing from plus 7 to plus 4, the difference is 3. So equivalent weight of KMnO4 is equal to molar mass by 3. So answer is second option. This should be clear. So please note down this in your classwork when you are discussing this question. Next question. A substance which is not paramagnetic is paramagnetic means it should not contain, not paramagnetic means it should not contain no unpaired electron. No unpaired electron. So if you see chromium ClO4 taken thrice means ClO4 minus 3, so it should be chromium plus 3. Chromium plus 3 state means if you take atomic number of chromium, chromium atomic number is 24. It has argon 3d5 4s1. So if you take 4s1, so if you take in plus 3 state, it becomes 3d3 4s0, because 3 electrons, 2 electrons from D, and so it has n is implies n is equal to 3. So it should be n is equal to 0. No unpaired electrons. So first option is ruled out. Second option, let us check. MnO4 minus. So if you take MnO4 minus, manganese oxygen state is 7. So if you take this into consideration, manganese atomic number is 25. So argon 3d5 4s2. So if you remove the 7 electrons, then it becomes, manganese becomes Mn plus 7 becomes argon only 3d0. So implies n is equal to 0, no unpaired electrons. So answer is second option. Since in KMnO4, manganese is in plus 7 oxygen state. Since in KMnO4, manganese is in plus 7 oxygen state. So it has no unpaired electrons. As it contains no unpaired electrons, it is not paramagnetic, it is diamagnetic. So answer, let us check the answer now. So the answer could be option B. Option B. Next question. Clearing this. Example 10 now. The most strongly ferromagnetic elements among the following is, straight away easily we can say it is iron, because iron is ferromagnetic, whereas cobalt, nickel and osmium are not ferromagnetic. Most means even nickel is also somewhat ferromagnetic, but iron is most ferromagnetic. So answer is A, option A. So answer is option A. You can see here iron is ferromagnetic. Next, the value of magnetic moment of B plus 3, that is atomic number is given 23, is, straight away you can find, since magnetic moment mu is equal to root of n into n plus 2. So magnetic moment mu is equal to root of n into n plus 2. Vanadium atomic number is 23. So first write the configuration of vanadium. Vanadium atomic number 23. So it could be argon 18, 4s2, 20, 3d3, 3d3, 4s2. So as B plus 3 becomes, then B plus 3 is equal to argon, two elements from 4s orbital will go off, and one electron, two electrons from 4s and one electron from 3d. So it becomes 3d2. 3d2 because one electron from d orbital and two electrons will, because it is in plus 3 state, means it should lose 3 electrons. So it is argon 3d2, means implies n is equal to 2 number of unpaired electrons. By this we can say mu is equal to root of 2 into 2 plus 2, that is equal to 2 into 4 root 8. 2 plus 2 4, 4 plus the 8. So root 8 is approximately 2.83 Bohr magneton. So answer is second option. So these type of questions are most important for entrance examination. That's why repeatedly we are discussing all these questions. So please note down. So answer is 2.83 Bohr magneton is equal to 2.83 B dot M. Next question. Which of the following electronic configuration will have the highest magnetic moment? Simple. So if you see here, n is equal to 2 in this case, n is equal to 4 in this case, n is equal to 5 in this case, and n is equal to 3 in this case, because D7 means electrons will be filling up like this. First electron, second electron, third electron, fourth electron, fifth electron. And then sixth electron will start pairing up, seventh electron. So this up to here it is paired. 1, 2, 3 elements are unpaired. So n is equal to 3 in this case. So, and we know magnetic moment mu is proportional to n. So mu is proportional to n means n is equal to 5 is the answer. Mu is proportional to n. So n is equal to 5 is the answer. So option C. Right. Next question. Which of the following ions exhibits largest magnetic moment? So calculate n values in all these things. Since B plus 3 we have seen already, n is equal to 2. And chromium plus 3, if you take into chromium plus 3 into consideration, chromium atomic number is 24. So chromium, argon, 3d5, 4s1. So out of which 3 electrons are removed means it becomes chromium plus 3 becomes argon 3d3, because 3 electrons are removed. So 1 is removed from S and 2 will be removed from D. So it should become 3d3. So implies n is equal to 3. So second option n is equal to 3. And third option, let us see third option Fe plus 3. So ion atomic number is 26. So argon 3d 4s2, that is 20, and 3d6 26. So Fe plus 3 becomes argon 3d3. Since Fe plus 3 becomes argon 3d3, so it has n is equal to 3. So B and C are same. Let us see in place of cobalt 2 plus cobalt. Cobalt, if we take into consideration cobalt, atomic number 27 is already given. So argon configuration I'm writing here 3D 4s2 20 and 7. So this should be cobalt 3 plus means argon 3 electrons means it should be 2 from, so 3d6, argon 3d6. So it should be n is equal to 4. So answer is fourth option, because mu is proportional to magnetic moment, mu is proportional to n. So n is equal to 4. Highest in this case of cobalt 2 plus when compared to vanadium 3 plus, chromium 3 plus, Fu 3 plus. So n is equal to 4. That is number of unpaired electrons. Answer is D option. Let us check the answer. So it should be 100%. It is not C. It should be D. I hope it is clear. Cobalt 27, 3d7, 4s2. So cobalt 2 plus, so 3d7 only 3. Sorry, here it is. I thought it is 5. So actually I have taken cobalt plus 3. I should take cobalt plus 2. So cobalt plus 2, if we take into consideration, argon 3d7. So n is equal to 3. And Fe plus 3, somewhere we have done mistake here. Fe ion atomic number is 26. So plus 3 means 2, and so it is 3d5. So N is equal to 5. So in Fe plus 3, you can see here, Fe plus 3, it is 3d5. So N is equal to 5 in this case. In this case, it is N is equal to 5. So answer is C option. It is not D option. Please note it down. So N is equal to 5. This is N is equal to 3. Again, I'll write here to avoid confusion. So N is equal to 3, N is equal to 3, N is equal to 2, and this is N is equal to 5. So answer is third option, that is C. Next question. Which of the following ions is diamagnetic in nature? Diamagnetic means they should not contain unpaired electrons. Unpaired electrons means N value should be equal to 0. So titanium plus 3, manganese plus 2, Cu plus 2, Zn plus 2. In all these cases, find N value first. So let us take Zn plus 2. From reverse will come Zn plus 2. The atomic number of Zn is 30. So Zn is equal to argon 3d10, 4s2. After removing 2 electrons, it becomes Zn plus 2 is equal to argon 3d10 only, because 2 electrons are removed from s orbital. So it has no unpaired electrons. So straight away, without seeing, we can say Zn plus 2 is having diamagnetic in nature because it contains no unpaired electrons. As it contains no unpaired electrons, so it is diamagnetic in nature. Remaining all, definitely you'll get unpaired electrons. You can follow the same process with respect to titanium, manganese, and Cu plus 2 also. Definitely you will find N value is equal to greater than 0 in all these three cases. Since N is greater than 0 in all these three cases, it is not diamagnetic, it is paramagnetic in nature. If N is equal to 0, we can say it is diamagnetic in nature because magnetic moment is becomes 0. So weak repelled by magnetic field. I hope you have noted down in your classwork. Next question. If a transition metal compound absorbs violet radiation of the visible region, its color would be very important question. So if it absorbs violet radiation of light, then its color will be yellow green color. Its color will be what? Yellow green color. Next question. Transition metal compounds are usually colored. This is due to the electronic transition of from s orbital to p orbital, from p orbital to d orbital, s to d orbital within dd orbital. So already we know answer is D because transition metal exhibits color due to the dd transition. They exhibit color due to dd transition, and in exception cases, it is also due to charge transfer phenomenon. Charge transfer phenomenon in case of MnO4 minus, which is green color, even though it contains no unpaired electrons. So usually most of the transition elements are colored due to dd transition. So transition within the d orbital due to electronic transition. So let us check the answer. So answer is D. So please note down this clearly. Most of the transition metals are colored due to dd transition only, and some transition metals are colored only few. That is like example, manganese ion is colored due to charge transfer phenomenon in case of MnO4 minus from oxygen atom to manganese atom. So that's why it is colored even though it contains no unpaired electrons, and remaining it is due to dd transition only. So please make a note. Definitely it is helpful in the entrance exam. Next question. Which of the following ions is expected to be colorless? Colorless means no unpaired electron. It should not contain unpaired electron, no unpaired electron, and it is diamagnetic in nature. It should be diamagnetic in nature. So these are said to be colorless. So in which case Cu plus 2 it is colored because it is blue color. We already know it is not a colorless. Ta plus 4, let us check. Ta plus 4 is the answer. Fe plus 2 it has 3d5 configuration, so it is n is equal to 5, and V plus 3 it is 3d2 configuration, so n is equal to 2. So in this Ta plus 4 it is 3d0 configuration because 4 electrons from titanium is removed, so it becomes 3d0. So 100% n is equal to 0. So answer is first option. Since it has no unpaired electrons and diametric in nature, it is said to be colorless. So electronic configuration is most important in all the cases. So you have to note it down like this. Next question. Which of the following statements is not correct? The oxides of transition metals in their lower oxygen states are generally basic. This is absolutely true because they are ionic in nature and basic in nature. Second statement, the oxides of transition metals in their intermediate and high oxygen states are generally amphoteric and acidic respectively. This is also 100% correct statement because transition metals oxides in their higher oxygen states are either amphoteric or acidic in nature, and transition metals oxides in their lower oxygen states are generally basic in nature and ionic in nature. So these are basic ionic and these are acidic and covalent. Mixed iron oxides is found in mineral magnetite. Magnetite mineral is formula Fe3O4. So it has mixed iron oxides. Silver oxide is soluble in ammonium hydroxide following the complex silver ammonia hydroxide. So definitely the answer should be D. So the answer is option D. Because magnetite formula is Fe3O4, so it contains Fe2O, FeO plus Fe2O3. So it's a mixture of FeO and Fe2O3. So this is the answer correct. So wrong statement is fourth option. Silver oxide is not soluble in ammonium hydroxide, forming the complex. So this question is very important regarding transition metal compounds. Fe3O4 is the formula for magnetite. It's consisting of FeO, that is plus 2 state, ion in plus 2 state, Fe2O3, ion in plus 3 states. Together, its formula is Fe3O4. So it contains mixed iron oxides. Next, continuation. Which of the following statements is not correct? Gold oxide is soluble oxide. Zinc oxide is amphoteric. Zinc oxide dissolves in ammonium hydroxide and forms sodium zincate, that is sodium zinc hydroxide. And mercuric oxide exists in two forms, red variety and yellow variety. So answer is C. Zinc oxide cannot dissolve in NaOH and forming NaZnOH taken there. It forms sodium zincate, Na2ZnO2. Which of the following ions forms white precipitate with H2S? Which of the following ions forms white precipitate with H2S? This is a theoretical question, so you have to remember the answer. So answer is cadmium sulfide, cadmium, because cadmium on reaction with hydrogen sulfide forms cadmium sulfide, which is a white precipitate. So cadmium combines with hydrogen sulfide and forms cadmium sulfide precipitate along with hydrogen gas. So cadmium sulfide precipitate, it is white color precipitate. White precipitate is formed. Next question. The increasing order of acidic oxides of chromium follows the trends. Chromium follows the trends. Acidic order. Acidic oxide means already we know metals in their higher oxygen states. Metals in higher oxygen states. Higher oxygen states are acidic in nature. So based on that, easily you can find out. So here chromium is plus 2, so it is less acidic. Then here it is plus 4. Sorry, 2x minus 6 is equal to 0. 2x minus 6 is equal to 0 means, so x is equal to 3. So it is plus 3. And here it is plus 6. and here it is plus 2, here it is plus 6, here it is plus 3, and again here it is plus 3, sorry, plus 6, plus 2, plus 3, again plus 6, plus 3, plus 2. So answer is straight away you can say first option, because metal in higher oxygen states are acidic in nature. So CrO is basic, Cr2O3 is amphoteric, CrO3 is highly acidic in nature. So answer could be A. Is it clear? Next question. The lanthanides and actinides are collectively known as, we already know it is inner transition elements. The lanthanides and actinides are collectively known as inner transition elements. So option is C. Next. Which of the following statements regarding lanthanides is not correct? Like this statement based questions, as I already told you, from general properties of D and F block elements, definitely you'll get statement based questions. So you should be thorough with all the general properties of D block and F block elements, because from general properties only most of the questions will come. The compounds found by lanthanides are covalent. The color of the compounds of lanthanide elements having XF electrons is often similar to that of the elements having 14 minus X F electrons. So color is similar. This statement also we have seen in general properties. So this is correct. And first one, second one. So next third one we are seeing next statement. This question is not completed in one this thing. Except lanthanum plus 3, cerium plus 4, and rubidium plus 3 salts. All other compounds of lanthanides are paramagnetic. Yes, it is true because they contain unpaired electrons. So third option is also true. Next, the pairs of zirconium, hafnium, niobium, tantalum, and molybdenum tungsten have nearly identical size. So answer is fourth option is also correct. So definitely the answer could be the compounds found in lanthanides are covalent is wrong because they are ionic in nature. So this is wrong statement because they are not covalent. They are ionic in nature because the oxides of lanthanides are basic in nature. So basic means they should be ionic. So answer is for this question option A. Option A is the right answer because remaining all the statements are absolutely right. Lanthanide contraction is due to, as I told you, this question is very important. The consequence of lanthanide contraction, definitely they'll ask in so many years, so many entrance examination, they have asked this question. Lanthanide contraction consequences, that is nothing but the effect of lanthanide contraction. Lanthanide contraction is due to ineffective shielding of nuclear charge by 3D electrons, ineffective shielding of amongst 3D electrons, ineffective shielding amongst 4F electrons. So answer is third option, and decrease in electronic repulsion is wrong. So option is only C because it is found in 4F and 5F electrons. So ineffective shielding amongst 4F electrons. It is only due to, and consequence of lanthanide contraction is also important. That also you please study. I have given clearly in the lectures. So answer is third option. Next question. Which of the following elements has the largest atomic radius? Radius means it depends upon the atomic number. But here neodymium, samarium, europium, and gadolinium. Europium could be because europium has largest atomic radius because it contains 63 means 4f7 configuration. 4f7 configuration in ground state only. Ground state. So that's why it is having largest atomic radius. So that's why the atomic numbers are very important to remember. So, and before this, so this is the last question we have discussed. So I'll write the summary of the chapter. So here, as the place is there, I'm going to write summary of the chapter. Simply summary of the chapter for D and F block. Summary of the chapter. for D and F block. First point, general characteristics. In both D and F block are important. Definitely you will get questions from this only. All the general characteristics. Second one we have preparation and properties of potassium dichromate and potassium permanganate. Preparation and properties of K2Cr2O7 and KMNO4, as these two are good oxidizing agents. Next we have, so this is only 2 star I'm giving. Next we have uses of lanthanides and actinides is most important. Like mixed metal, it is 95%, it can form an alloy. It is 95% of lanthanides and 5% of iron. So use of lanthanides and actinides is important. So if you could concentrate on all these three and questions which we have discussed so far, all those questions are very, very important, especially the like magnetic movement, electronic configuration, half field, complete field, lanthanide contraction. So all these points are very important. In a block, especially consequences of lanthanide contraction is important. Consequences of lanthanide lanthanide contraction is important. So please note down all these things. This is more than enough for D and F block. Definitely you are going to get 3 MCQs from this chapter. So 3 MCQs, whatever we have discussed from that only you will definitely get. That models are important. So all those models, listen carefully and practice and do some other material like Jayendra material or any other objective material, competitive book material. Definitely you will get perfection in this chapter. So please do what we say and follow it clearly. Definitely these are going to get 3 questions, 3 MCQs from this for Neet as well as JE means you will get for Neet and JE means. So that's why this is most important chapter. So follow the instructions given by me and do it accordingly. Definitely you'll get success in the examination. So please note down these 4 topics and do accordingly. So with this, I'm closing the session. So please do accordingly all these questions. With this, I'm closing the session and follow accordingly strictly whatever we have discussed in the lecture. Thank you all.